WordPress app in our own custom storage and the volume or the network we use. So that was a very kind of fascinating class we have done in the last few classes. Today we are going to go more deep into Docker. Okay, and there's one more interesting topic we are going to start today. Okay, that is related to Docker file. And what is Docker file? Whenever you want to create a custom image, there's a role of Docker file come in play, right? But there's a concept, guys, in the Docker file or in image building. There's called multi-stage build. So very important concept, and we use this concept a lot in today's world and today use cases. Or if you go to any DevOps job role or Docker related interviews, this is a very common topic they will ask you always. Okay, because by this topic we can create a strategy, also multi-staging strategy or multi-stage strategy. Okay, that we use a lot in the world of DevOps, CI/CD pipeline. And second thing is also help you in shrinking the size of Docker image. Okay, so if you want to create a small image, very smaller images, that's also this topic help you. And why we need a small image, that's also we discussed today. Plus this topic has one more relation with one more topic called distroless images. So that's also, guys, we will talk today. So there's multiple topic related to the main key topic for today. Multi-stage build is a key topic what we are going to start today. Is very interesting topic and very important also. But before this, let me explain you what we know already till date. Okay, the thing that we know till date in the Docker file respective is, with the help of Docker file, what we do, we create a custom images. And this process is called build process. So we do build to create custom images. And why we need custom image, that we have a specific use cases. I want an image. I want an image, okay, that will help me to provide my personal libraries, personal version of the runtime, person app, environment, and many things that what we can put in the custom images. And images are the thing, guys, that is the one who help you to launch the container. Okay, this called run the container. The good thing and the good powerful thing of the Docker is, from the image launching that container, okay, will take 1 second or less than the 1 second. But again, this statement is not perfect. Okay, how much time it will take to run the container, means launch the container is the one who run the app. Okay, it all depend upon many factors. They're very less, even though second, 1 second, 2 second, or half second maybe. But one of the factor that these guys depend upon the size of the image. Okay, because image is the one who will launch the container. Image is the one thing that is there in the hard disk, right? Image like you can think like a bootable OS. That's there in the hard disk somewhere. And when you run the container, create a new container from the image, it contains the one like OS that run on the memory RAM, right? Okay, if the image is bigger in size, you take some time, right, from storage, that's called hard disk. If you want to load something on the memory, right, it will take time, right? Time. It means, just hypothetical number, if the image is 1 GB in size, it might take 1 second, for example. It all depends upon what is the speed of your hard disk and many other factors also. Okay, if image size is 2 GB in size, it might take 2 seconds to launch the container. So one of the factors that will decide how much time container will take to launch is vary from the size of the image. it means it means we have to do some strategy that will help us to shrink the size of the image, or we want to create a smaller images. When I say smaller image, I mean to say in respect to size of the image. And there's a lot of strategy, guys, we can think of in creating the image size smaller. One of the area that will help us to create the smaller image, one of the way is using multi-stage build. I'm not saying this is the only way, okay, but this is one of the way in some of the use cases. And again, it is not very from all, it is not apply in all the use cases. In some of the use cases, wherever we can implement multi-stage build, in those use cases, I can use the multi-stage build topic and create the images a smaller size. And smaller the size of the image would be, so smaller the size of the image would be, faster your container will launch. Even though faster does not be like 1 hour or 30 second or 30 minute or something, it will be within 1 second, 2 seconds. But in the bigger environment where you launch thousands and millions of container day and a week, then this 1 second also makes a lot huge impact and change, right? This is one point. Now, what is multi-stage build? Let me explain to you. So technically, whenever you want to create a custom image, why we want custom image, that we use a Docker file concept. In the Docker file, guys, there's three main keyword we use. One is called from keyword. Okay. And from keyword means I want to take some of the pre-created image by some community or by you or by some XYZ company. Okay. So that base image we use. Okay. Let's say this base image, one of the example we use Ubuntu, or let's say we use Red Hat, let's say with version, let's say 8 or 9. That base image we use given by Red Hat as a company. Okay. But this is just a base image. Okay. And what this image provide you is all depend upon what this image given by some company provide you. Maybe they might give ls command. Maybe they might give you Python pre-installed. Maybe they might give you some other command as a date command or the ifconfig command and so on. So it's all depend upon what these guys have provided you in the image. Idea very simple. More commands they give you, more binary they give you, more different folder and file they give you, the bigger the size of the image would be. would be. Now the point is, from this base image, I'm going to create a custom image that is provided by some company or some distribution. Is called distro. Okay, and whatever they provided you, all those binary command file and data, do you really need this? Do you really need this? Okay, because more things they provide, more binary they provide, the bigger the size of the image would be. And this would be a base image. And on the top of this base image, I want to create more content on the top of this according to my requirement. Okay, so let's say this base image, after they giving a lot of files and folder and commands, let's say of size 100 MB. Okay, but I don't want this image as is. I want to add something. And when I want to add something, then you use a run command in the Docker file. And with the help of your run command, you will add a lot of data. How? By installing the software, for example, yum command, for example. Yum is one of the command we use in Linux, Red Hat. And let's say using yum command, I install, let's say, Python or Java or maybe MySQL database software. So yum is what they're helping to install software, means they add many more data, files, and commands on the top of this. That means the base image has given you data of worth 100 MB size. They might add 200 MB more, or let's say 20 MB more data on the top of this. Okay. It means finally, if you build this image by using these two keywords, from or run, okay, the total size of the image that would be your custom image would be 120 MB in size. But out of this 120 MB in size, do you really want the image to so much big? Okay, do you really want every data, whatever you added? Obviously, you need this data, this software, or there may be some other software what we have installed till date, because this is my specific requirement. This is what I want. But the base image has given you many more things from the distro. Okay, and they have given many more things, many command. I'm not going to use ls command or date command or Python software or ifconfig my final custom image. If it does not need if it does not need these binary and these commands in your final image, so there's no good reuse, okay, to have these command and these data from that come from the base image. So what you can do, either you will take the base image and then before you use anything, you can use one more time run command and try to remove by somehow all those things command, whatever you're not looking for. More you remove, more data you remove, lesser the size of the base image, then lesser the size of the final custom images, and lesser the size of the custom images will help you in two things. One, okay, launch time will be shrink. That's what we want. I want time to be very quick. And second thing, guys, image is one thing that we keep on sharing. So what image you create, you share to other team. And bigger the size of the image, it obviously takes some time to share, to upload and download. This time also wants to decrease, right? So there were multiple regions, multiple reasons that why I want my image size to be smaller. But there's one more way to think of. Bigger the size of the image means more data they have, more command they have, more executables they have. And whenever you have more library, more command available, it means there will be higher chance to have more security threats. Okay, why? Because we don't know which command and binary has some security vulnerabilities, right? It is more like this, more area you take, more surface you take, more chance there will be attack. The attack can become from here, and here, from here. The bigger the area would be, this surface area, then there will be more chances of any attacks happen from any area of your surface. It's called bigger surface area attack. And when you want to safeguard yourself, try to squeeze the area, try to have a smaller area, try to use only those area, that much space. There's much things that are what you need is minimal things we can use. So the chances would be there will be less chance to have any security threats or the vulnerability and the attacks. Okay, because I want my surface area to be smaller or the minimize. That is equals to the minimum image, the smaller images. So lesser the size of the image is, lesser the text will be, lesser the time to take upload and download, lesser take to content to be launched. The point is, I want my image to be as much as minimum as possible in respect to size. Okay, that is one thing. And to achieve this, one of the way or strategy is using multi-stage build. There were many more also. So multi-stage build will help you in this point. Okay, so for this, in the So I'm just taking as an extra example here. So if you want to have a have a what I say, the image of smaller size, then instead you can use distro images from Red Hat or from Ubuntu. There's a concept called distro less we can use. So we have a separate topic on this distro less. We'll talk in some time. But distro less is the one of the thing we can use where my image won't have any SS distro. What we don't have anything, whatever these extra company will give you from their distribution. Red Hat has their own command ifconfig. I don't need it. Or Red Hat we have the yum command. I don't need this. Okay, in my requirement. So I can go for distro less images. Okay, you can think is a bare minimum smaller footprint images, and I can add what I want to add on the top of this by using run commands. So from would be distro less images that I'll talk in some time. That is a very small size. And then what I want to add, you can add. So let's say they come with a 10 MB size, for example. And I don't want anything, so they then zeros give anything. Minimum 10 MB, for example, they give you, and I had 20 MB data from my side with a run command, the build command, then obviously the final size will be 30 MB instead of 120 MB. So very small compared to 120 MB, right? There's something like this. So we'll talk about distro file, distro less images in some time. But right now, the main topic, I just want to give you some vocabulary because this vocabulary I want to use again and again in today's class. That's what I'm just giving you some vocabulary today. Okay. With small concepts discussion also. But today main topic is multi-stage build. Okay. So what I've given you as a quick information, because this information I will relate again and again. Okay. But let me start. The main key topic for today is called multi-stage build. Based on the topic what I explained to you, let me talk about this topic. Okay. So, guys, whenever you create an image, okay, this called custom images, okay, what we do mostly, we always take some base image from the from keyword, okay, and then from the base image, again, let me take the example of Red Hat version 9, for example. Then, depend upon my app, whatever app you are going to run, your Python app, your Node.js, JavaScript app, or you have a Java app. Okay, if it's Java app, then what kind of app it is, which library they're using. For example, if it's a web app, they might be using Spring Boot, for example. For example, Python, we have Flask, and Java, we have Spring Boot for web API framework. Okay, so let's say you're using Spring Boot app. So the minimum requirement is, okay, and because one more thing, you might know, if your app is Java, Python code we can directly run because Python is an interpreter. But the code that is written in Java, you can't run directly. Okay, so in the world of Java or C or Go language or Golang languages, whatever code you have, source code you have, first compile it. And after compile, okay, then because when I say code, when I say app, it means there's a lot of files we have, file 1, file 2, file 3 of Java. It compile all file and we put together all file and create a package like a software. And the software is the one that we run as an app. Okay, for example, it's a mobile app, then we have a package called APK file, for Android. Or if it's a website, then package would be a kind of extension.war file. Web archive in Java package or software for running the Java app. So technically what we need, just I'm taking the example of Java, we have a code written in Java as a language, then we compile this code, if you know Java C command to compile, then this software, whatever I compile, I create a package by somehow, and then this package will run with the Java command. give the package name, and they will run for you. Your app will start. Okay, but the point is, who will help me to compile? Because when I say my code is compiled, but in code, guys, mostly what we have a lot of libraries include. In comparison, we need all the library to be included, then only the compile. Okay, and anyone who work in Java, there's a lot of libraries, a lot of library dependencies. So we want some tool to help me to download all the dependent libraries, and then they help you compile. One of the very famous software you might know is called Maven. So Maven is the one that I can say, Maven, please go and take the code, look at the code, and by looking at the code, code, just download all the library that when on which this code has been created, and then compile the final code. Final code. And after compile, Maven is the one, I'll tell the Maven, then finally create a package, the code file. So Maven is one tool who can help you in this all this thing in the automated way. And in the Maven world, this part is known as build. We're building the Java code, and after build, this part is called package. We are packaging the Java code. Okay, or typically this both the guys together known as, let me use the quick word because this is not the Maven training as such, but this all this two part technically in the world of Maven are known as Maven build. So building a package so that we can run it. We can run it. Okay, so this guys one thing I have in the Python we don't need, so because in the Python the code we directly run. There's no compile thing, right? But if the code is written in Java, then we have to compile. And for compile, we need a Maven kind of tool. That means if you want to create a custom images, okay, where I want my biggest image to be read in line, and on the top of this, on the top of this, okay, you want your code to be written in Java, and you want the code to be compiled or built as a package, then what you have to do, you have to first install somehow Maven. Okay, because Red does not give you Maven, so you can use your run command. And guys, this is what respect to Docker file I'm talking about. Okay, so what you see here, this side is just a concept I was talking about. What I said, this side, this is a Docker file I'm talking about. So somehow you install Maven. There's multiple way to install Maven. Let's say this is one of the way. Okay, and after install Maven, then you can use a copy command, and whatever app you have a Java, this app from a base system, you copy to your new custom image. Okay, so the software installed, app installed, and because this is Java app, then you have to install Java software also, mostly the JDK, Java Development Kit. JDK you have to install, and then finally ask them Maven, okay, and say what we want to do. I want to create a package, okay, that is there inside this folder. So whatever code we copied into this folder, I'm asking Maven, go and build it. Go and build it. Okay, and for building, there's Maven multiple command, Maven build, Maven compile, Maven package, Maven test, many things we can do here. So this also we run. So this command, I'm not giving the exact command here, I'm just giving you a concept actually. Okay, so the base system image is only giving me yum command. The yum command is using to install Maven software, installing Java software, then copy command on Docker, I'm helping me to copy the source code into the new custom images. Then this Maven software give me MVN command, Maven command, help me to create a package. After package created, there's a war file. Okay, then we run the app. And you guys know we always run the app when the container launch. But right now, what I'm doing in this Docker file, these part what I am writing here, I'm doing at the build time of the Docker image. That's what I discussed you multiple times. The run keyword, copy keyword, especially run keyword, the build time keyword. But when I say build time, it means my base image, I'm going to add a lot of softwares, my code, and I compiling my code and creating the final package software. But after software created, okay, let's say I'm creating software with a name called linuxworld.war file somewhere here. Then I can ask my Java command, because the Java software in Java, there's one file, jar file or war file. It there into this folder wherever you created. Okay, I want to run this program. But this is a program, this is a final app, and we don't run the app. We can run if you want, but there's no good reason. We don't run the app at the build time of the image. We run the app at the runtime of the container, means from the image when container launch. And for this, we can use CMD keyword or the entry point, right? That's what we use. Entry point and CMD, what I discussed to you already. So there's a keyword from the Docker file that we use at the runtime of the Docker images. Okay, runtime. So this is what the step we have done. But understand one thing. In this step, the first step is common almost in all the use cases. Okay, we have to use the base image, Red Hat, Ubuntu, or something else. Now it is your choice. You want to use the base image from the distro like Red Hat. If you use so, then they give you many more commands that you're not looking for, that become the final image size very, very high and big in size. And plus, they also there will be possibility of bigger surface area for the attack. Okay, or you want to use a distroless image. Distroless image. Okay, for example, your requirement is to use the Maven. Okay, so why not we can use the image that give you only Maven, or minimum thing whatever Maven need. Or why don't we use only JDK software and minimum thing whatever JDK need? They does not need ls command, they does not need Python, they does not need ifconfig command, they does not need ls command. ls command. Guys, can you host for a second? As I'm come back in 2 minutes, guys. Just give me 2 minutes, please. Rather than you can use some base distro images like Red Hat or Ubuntu, because our ultimate goal is to install to install, let's say, the Maven or then Java, or mostly in the Maven is dependent on Java, so we have to install Java and the Maven. So what we can do, we can search, do we have any image? Now, any image, let's say if you search in Docker Hub, and we can check, do we have any image respect to JDK? That means Java. Okay, or maybe you can search Java, so you can find JDK image from from chain guard. Okay, and maybe many more you can find. But let's say if you go for this image, okay, and if you go for this image and try to download this image, then you will find let me go for different example. Chain guard, this is what I'm trying to tell you in a minute. Okay, chain guard is very, very powerful repository. But let's say I'm looking for just Java admin search. Or let me use search for OpenJDK, is open source Java. Okay, if you go for this JDK, open source Java, it's a 1 billion downloads, so most of you guys use this. If you download this image, you will find this image have pre-Linux installed. Okay, and then on the top of this, they have given you pre-Java installed. That's what we're looking for. Okay, but this is not the distroless image because they give you many more things from base OS that is not required. Which is base OS they're using, maybe Windows or maybe Linux. We does not want, for example, they might use Oracle Linux, for example, from this. But if you search, so that makes this image size very big in size. Okay, big in size because they give you many more extra component that will increase the size. But if you search for Docker distroless images for JDK, okay, then you can find one of the link that's called Google Container Tool. Okay, that is one who mostly promoting a lot for the distroless images that only contain application. Okay, that does not contain any shell or any other program or any package manager like yum command. Only focus on what we need. And here you can find a lot of images. For example, I'm looking for Java, so this Java, and here they give you these examples. This is the image, base image. Okay, and if you download this image, you can see there's a huge difference in terms of size. So this will contain base Linux, maybe they contain pre-installed Java. In this case, Java version 17. I think they're using Debian Linux. Okay, this is the URL of where the image is located. Just copy this URL and wherever your Linux would be. In my case, this is my Linux. Okay, if you use Docker pull and download this image, download this image. So when you look for this image, Java image, that will give you what we need in the Java. For example, I am needing Java jar command. Okay, that I want to use somewhere in the CMD or the entry point. So this image give you pre-installed Java command. This goes Java runtime, this goes GRE. So I can run my app. Instead, they will give many other things that I'm not looking for. Okay, so if you say very quickly, if you offer to download this image, if you run the images command, okay, you can see this image is 226 MB in size. But if you try to compare with this image, if you download, okay, they also give the same thing, but a lot of unwanted things that I am not looking for. They've increased the overall size of the image, that will increase the overall size of our custom image. If you take this as a base image, plus also increase the security threats or the vulnerabilities. Okay, so requirement would be based upon based upon uh, your custom images. Try to find your base image should be distroless. That's what I'm talking about at this point in time. But yeah, I'll come back to this same example again. So base image you want to use as a distro image, pure Linux OS, then setting Maven and JDK by yourself, or you can use the image that is pre-installed with Maven or JDK from from Docker Hub. So here also you can find an image that is Maven installed. Okay, when I say Maven, it's the official image. When I say Maven, it means they have some base Linux, plus they have Java pre-installed because Maven does not work without Java, and plus they have Maven installed. Again, that is not the distroless images mostly. Okay, if you download this image, you find this image is very big in size. Okay, and give you a lot of extra things from the base distribution, hopefully Linux or Debian, whatever they use behind the scene. Okay, or you can search for same way Docker distro less Maven images if it's available somewhere. Okay, so you can find somewhere some link if you find the Maven image available. So that's the point, right? Otherwise, we can also create the distroless images by ourselves. How we will see. My point is, you can use any images. The recommendation is always nowadays use distro less images of the tool what you're looking for. Otherwise, you can create your own. How we'll see. Okay, but the next thing is from is one thing we need, and entry point is one thing we need. CMD we need. Okay, we need because this is the one who helped me to run my app. Who run my app. Okay, but if you talk about this part, especially this part this part we does not need in all the use cases. If it is a Python app, then we have to install Python software in the Python library, or you can use distroless image of Python with pre-installed Flask library, or we can use pre-installed Flask base images. So this part, let's say we already have the image pre-available, that's my base image. If we talk of the Python Flask, for example, that was the example we use a lot. Okay, but this part we don't use in Python. With Python code we directly run. In this case, we run with entry point or CMD keyword. Python code we don't compile, we don't build, we don't create a package. Okay, the code we have, we directly run it. That's all. Okay, we don't build. But if the code is Java, then we have to build it. We have to create a package. Then only we can able to run. Okay, this is one thing. It means if I create this diagram one more time, little more clean diagram, then you understand what is the actual topic for today. Let's go multi-stage build. Okay, so in the Docker file, that is help you to create your custom images. Okay, from is the one keyword we use, which base image you want to use, distro or your image that is pre-given Maven or Python Flask or Python or Java. Entry point or the CMD keyword we already need, that which my app I want to run automatically when the container launch. Okay, but in between, do you want to use any command that will help you to build your app? Okay, guys, this is not for Docker build. Docker build is a different concept. Docker build command that will help us to kind of compile this code or build this image from this file. I'm talking about building the app. In this case, maybe. Okay, so do you want your code, whatever you're copying from somewhere? Okay, so in my case, you code is Java or Python, you have to copy always, but you want before your code run by entry point. Okay, do you need to build the code or not? So it's all depend upon, guys, what the code you're copying from the source code, which language they have created on or developed on. If they developed on Java, code is created on Java or Golang or other language, some other language, maybe obviously we have to build. And for building, we need a lot of softwares. We need kind of entire JDK, Java development kit. Then on the top of this, we need Maven or Gradle, many other software available. Then we need a lot of libraries of the Java that is downloaded by Maven that will help us in building process. Okay, but this step is one-time step. After build complete of the Maven, then we have a package, Java package. And this package, okay, will give to entry point and they will run with the Java command. Command is that I told you already, Java jar command. This is a command that we use to run the Java app. And this command is run by entry point in the Docker file. Here I give him a package name. In this example, okay, whatever you see, this side is one-time step. What do you see this time is the thing that I want to do again and again. From a custom image that we create a Docker file, from this custom image, whenever my container launch in a day 100 times, 1000 times, this is the things I always want. Okay, things that you always want is you run your app. But who will run the app? Your container. From where? From the custom image. So if you're the things that you want always is a container, and the container I want to run my app, and this app will run automatically by entry point or the CMD keyword. Then what you want always, this part. So if you only want this part always, so why don't you keep only the package in your image? Package means your app, Java app in this example. And for running the app, what we need? Java. This is called Java runtime, JRE. In this case, Java command. Why only keep the Java runtime only? Okay. Why you don't keep only this part in your final custom image? Okay. Because to running the app, I don't need JDK complete software. I don't need Maven. I don't need a lot of libraries that help in the build process. I only need these guys only at once, only when my package is building for the Java or jar. Or jar. But after package build, then the remaining portion, okay, what do we have with this side? We don't need. Even though we don't need code also. Because sometimes code is also contain a lot of many things also, a lot of documents, many other things also. We don't need. We just need final package. Means the final image. Okay, let me use the word final image. The final image from where you want to launch a container, it's called app container. Mostly use the word app container. Need very minimal thing. We just need JRE Java command and we need a package. That's all. Even though we does not need everything about the OS also. I don't need ls command. I don't need if config. I don't need cat command. I don't need shell also. Okay. So even though I can use some base image, there is a distro-less images here. That are nothing. That will do only, they will give you environment that where only we can run Java commands. A Java command help me to launch my app. So technically, if you see, you file an image, if they only contain your distro-less, this very minimum thing of the OS, with only Java command and only your package, whatever you build, so custom image will be very, very small in size. It is so small. For example, in normal cases, if your image is like 1 GB in size, if you use this process, what I'm trying to tell you in a minute, okay, custom image can be 20 MB, 50 MB, 10 MB, or 100 MB. So much size will be reduced of the image if you follow this strategy. But right now, till now, the strategy what we're following is this. In one Docker file, we're using the base image. Same Docker file, I'm using the build command, Docker build command, and Docker build command is the one who uses the Maven command. Maven command is the one who download all the packages, all the library of Java, they're building the package here. And same Docker file we're using for entry point. So till date, okay, we're using one Docker file And from one Docker file, I'm creating one single image. And this single image contains everything. Entire content base image, entire content of your run command, JDK software, Maven software, your code, plus Maven is also libraries, and then final package or entry point. Okay, but this custom image is the one through which we launch a container, and the container is the one who run my app. But when my container run, my app is run, we only need this command, we only need Java command, we only need a package, we don't need Maven command, we don't need this packages, not the package, the library that Maven is download for creating this package or build. We don't need JDK and that software, we don't need the code also. Okay, even though we don't need my other base OS also. Okay, whatever they use, because maybe it might need Red Hat 9, for example, or Ubuntu. So they need some bigger OS base image of 2 GB in size. But when I run my app, I don't need 2 GB base image or entire Red Hat or entire Ubuntu. I just need very minimal OS that will help me to run only Java commands. Okay, so till date, we are putting everything in one custom image of Docker, or we're putting everything in a Docker file that help you to create customers. But the customers is so big because they are containing a lot of unwanted content we do not need finally in the final image. So what we can do now, this one Docker file, there's one file only now, but this file we divide in two parts. One part will be for the final image, what you want in the final image. And final image is the one, guys, that is the one that we want to run. So maybe I can use the word called run. So what you want finally when you want to run from the custom image to the container. What do you need finally? Okay, there's one portion we can define, and one thing we can define. Okay, what you don't want finally, but you need initially in this process. What I show you in the left side already. And this process mostly we use the word called build process. Okay, so a build mostly here does not Docker file build. Here the build means is depend on the app. There's a Golang app or Java app. So in the Java app, you want to build the package. Okay, so in the app build process, okay, whichever command you need, we define separately. And tell my Docker file. Now, Docker file, you are one single file, but technically, what you have to do, you are the one who give me the final image that I will run as a container. But but in this final image, I need some. In my case, I need some Java package. But to get this package, you have to run first this step. So I can say my Docker file you divided two steps, and these steps is nothing are known as stages. So here I can create two stages. One is stage number 2. These are no stage. I can say this is a build stage or this is a run or final stage. So as a Docker, you will run the first stage that's called build stage. And what to do here, you can do whatever I explain you in the left side. Take some from base image, and this image is a base image. Does not matter. This could be 1 GB in size, 10 GB in size, does not matter because this part we have to only run once. So here, if you use bigger images, that's okay. Because maybe might need this, library might need this, JDK might need this in the build process of the Java code to get in the package. Because this part we are running only once, and this part we are not sharing to any of my clients, neither my team. We are not running this part into my final production environment. So it does not matter. The size would be big. It might take some time extra. That's okay because we are doing only one part. Okay, so this is my stage, build stage. But after this part done, this stage give me a final output that's called package. Now from this stage, I'll take this package and give them final stage or run stage. Okay. So this stage, I will again create custom image, but this custom image, okay, I'll take the package what this guy has provided me, build stages provide me, okay, this package. Then I only add the minimum thing GRE, the only Java command. And again, to run the command needs some OS. I'll use some very small images. That is a very small footprint of the OS and minimum thing of Java. What we need. It's called distroless images. So in the final image, what do you see? Only distroless image gonna come up, or maybe be very small image of, let's say, Ubuntu or Reddit wanna come up. You can use anyone. Then only they give you only Java and plus the package. So this will be final image, and this image that we are going to share to your team. So image small in size, sharing will faster. This is the image that are going to store somewhere that takes less space. This image will load in the RAM as a container. When you launch, they'll launch very quickly. And this image is very small in size, have minimal things. So your text surface area will be very less. So there's a very less chance to have some security vulnerabilities. Technically, in one go, everything has been solved. Okay, and one Docker file, if you divide into multiple different portions, that's called stages, then it's called multi-stage build. So this is the topic, guys, we are going to learn today. Multi-stage build. So if we are building the Docker image, but divided into multiple portions, that's called stages. But it's all vary upon what kind of images you're creating. For example, if you try to create a Python image or Flask image, so there you don't find okay any good use case to use multi-stage build. The way we have done till date, that's what we have to use. Only thing is, instead of using Red Hat image or Ubuntu, you can go for some distro images, distroless image of Python. That will decrease the size of your final image of the Python Flask. Okay, because in the Python app, we are not building any Flask app, so nothing come in between that is need extra, and we does not need in the final app run. So we go to Python Flask, and the runtime we need a Python command. My Python app will run. They need a Flask library. So finally, also we need everything. What do we need in between? Okay, so there's no good use as such. In the example, what we have seen till date now in the Python Flask app, but if using Java example, okay, Java example, then obviously multi-stage build makes a lot of sense. Okay, so that is the reason I was talking about multi-stages topic. Who help you to plan this? This is called strategy of creating your final image. Okay, and by chance, this strategy they also help you as a kind of side benefit that will help you in creating the small images. And creating the small images, we can take the help of distroless images. But multi-stage build has no direct lesson with the small images and the distroless images. They're different concepts altogether. Mostly when you see a lot of blogs you can find on the net, okay, the topic name you always find is, if you want to create a small image, go for multi-stage build. So I feel this is wrong statement. It will not work in the example of Python or any other kind of these example app. Okay, the topic should be, the topic is multi-stage build. There we can use in some of the use cases. One of the use cases I told you today. But if you use multi-stage build on those limited use cases, okay, then one extra benefit they will give you the small image sizes. Okay, and creating those small image sizes, you can take the help of distroless images. So this is the better and the perfect statement to say. Otherwise, there are a lot of misleading document and videos you will find over the internet that does not make any real uh, meaning. That's what I can say. Okay. So let me take one example to make you this code understandable. So what I'm talking about, guys, I'm taking one example. This one famous project of Spring Boot. So there's a GitHub of the Spring project, and there's one project of Spring Boot is very famous. Most of the example you might have seen. This called Pet Clinic app. Okay, so this is the code written completely. If you go to source, completely on Java, completely on Java. Okay, so it's complete code written in Java. So this is Java source code that you don't need to learn right now. But this code is an app. For example, in my case, large example, you see code written in Python and they create a web app using Flask. Similar here, this is Java code. This is Java code. And they are creating the web app Spring Boot framework. It means to run this app, okay, we need Java obviously, and we need a Spring Boot libraries. More about library that Spring Boot will be dependent on. That is the reason we don't install the Java library by ourselves. What we do, whoever create this project, they create a file called pom.xml, and so this entire project was Spring Boot Pet Clinic app. This entire app, okay, using lot of libraries. There's a dependency. This library, this library, this library, this library. We get a big file for all the dependency. Many more things they write here. And this is the file pom.xml. Is not from Docker. Is not from from Java. It is the library used by Maven. Okay, so no library is a file used by Maven. So Maven is the one, okay, who use this pom.xml file. So whenever you take the help from Maven, Maven, they will explain to you. Always look for this file pom.xml. If this file is there, then Maven will take this file, okay, and take your code, compile the code. But before they compile, they download all libraries, whatever the code depend upon, and then they compile and they get the package. This is what Maven do for you. Okay, choice. This Maven command you want to run by yourself. Okay, so what you can do, this is a code you can download from GitHub, and this is Maven is one command, mvn or mdnw, and package keyword. So what code you download, go to this folder, whatever you download, and Maven, when you run the Maven command, obviously you should have Maven command on your base system, laptop, wherever you download this code with Java installed. Okay, so this command will automatically look for into this folder, this POM file, and then they download all the libraries. It takes some time and package a keyword to tell that final package. And after package created, they create in this folder with some name, whatever you find the POM file. The POM file we can write what is my final package name. When you compile the code, your final package will become with this name. This is your package name, is software name with this version. That's what they define, or maybe we can define this way also. Okay, so that's what we can define here, and then we can use Java command that you should have your laptop to run this app. And because this is a Java Spring Boot app, so they give you web UI. okay, in your local system on port number 8080, and this is how app look like. So this app, whatever someone has created, is look like this. Okay, but right now I does not want, because this is the main command. This is the one who run the app provide here. But this command I does not want to run in my local computer. I want to run inside my container. Okay, inside my container. But if you want to run inside the container, you want this in the image. So in the image, what do you want? You need entry point, and the entry point is the one who will help you to run this command. This was same command I was talking about here. So entry point can run your app when the container launch. Okay, but before entry point run your app, what do you need? You need a package, right? This command run 100 times a day. Keep on launching this app. But this package creation, this command is only one command. We need to run only once. We need to only run once, right? So, because this part you want to read only once, and this part we need a lot of things. We need JDK, we need a lot of library, we need maybe software. So this part we can run in different stages. Okay, different stage. This called build stage in my case. So let me show you this demo. But my plan is to give you the demo of this example. This is without Docker. Install Maven Java in your laptop, and you can run the app there. It will work same and give the output. But I want to build my app inside the Docker using Maven. I want to run my app in the container. Okay, in the Docker. Everything I want to do in the Docker world. That's the plan. So for this, let me download this code. I'll share this link to you. You can search also Spring Boot Pet Clinic app. This is a famous app in the market for testing purpose. Only thing is I need Docker running. It's running in my case. Let me also clean everything running in my Docker container. So everything is cleaned. Okay. Now let me create a new folder here. Code Docker is in the folder, nothing special. I use git clone command. Okay, and paste this URL, whatever I copy from here. So they will download it. This is a folder they create. I'll go to Spring folder, and here they download everything. So main thing, I need my entire Java code that I have. I need pom.xml file. That's also I have at this point in time. Okay. Now what I want here, 1 minute. I need to create Docker file. So first of all, guys, what I'm going to do here, okay, I am going to this part right now with the same way the way we have done till date. Okay, so that's what I'm going to do here. So till date we get only one Docker file with everything there only. This is what I'm going to use here. For this, what you are we will do here. So I will even though let me go out, and here let me create Docker file. I'll use a from keyword. Then I use, let's say, Red Hat 8. Then I use copy command. Okay, and I take this folder that contain my entire app. So I say in my current folder, entire app. I want to copy in one of the folder inside this base image. Okay, Then I installed JDK. Then we installed Maven. But typically, JDK and Maven is a very common thing we always need. So you can find a lot of pre images that give you Maven installed. So I can go to Docker Hub, search for these images. This could be one of the image name. Okay. So instead of Red Hat 8, we can use Maven image that will give base Linux with some JDK. Java means Java entire development kit and Maven. Okay. So I did note this part. So finally, I have a base image with Maven installed, Java installed. Everything is there in the pre-created image by someone. Then I'm copying my code. That's what I've done over here. Done over here. So let's do till here. What we achieve. Docker build, have a D. Let's say this is my Linux world Spring app version 1 and dot. Okay. Maven is, I don't have Maven in my laptop, so they are downloading the Maven image and then copying the code. Okay. Then what you achieve, according to the project, what I am looking for, this code I am copying into my image, okay, in some folder, and wherever copying, that always has Maven installed. So this image created. Let me very quickly check what I have here. Let me try to take a shell. If they have shell there, they have. So here I have copied my app to app folder. The app gonna come up because I copied. Plus this is the base image. See, there are a lot of commands they have, right? I don't need this command. Some command they have, some command they don't have. Okay, so there's not distro less image, so they give you many things. So some command they give you the shell also. I don't need shell. I don't need just to show, but otherwise when you run the app, you does not need this, right? So this because the image that I use is not distro less. Okay, so there's one point. So we have an app copy come up, and then if you search Maven command, so we have Maven command also there. Okay, so they have this command, but right now to run the Maven command, you have to first go inside the app folder where you copy the app, send the Maven command and say package. This command I'm using. Now what Maven do? Maven always look for this file. This file they find, and according to the file they download all the libraries, make this container very big or this image very big. Okay, and then compile the code and creating the final package. Right now I'm doing it manually just to show you, but this command we will run on Docker file. So when we build the Docker file, Docker will copy this code, run this command, the way I explained to you. And this is what is happening right now. Okay, so I use my base image. In my case, Maven. Maybe begin size that's okay. This part 1. So there are a lot of libraries. This is what you can see here. A lot of libraries they're downloading. Right now I'm doing it container, but when you do in the Docker file, that's what we do to make this part automated. So all the library, whatever they're downloading from the internet, they will be a part of the part of your. We don't need because Maven we does not need. We library does not need. After package created of Java, or I don't need Maven or any library, whatever they download. That download, what a download they're doing, I just need only once. Okay. Only for this process, what is going on at this point in time. Okay, but we put everything in the one file. So technically, this is the command I'm running at this point in time. putting everything in one file. So whatever they're downloading, what a software we're installing, code we're copying, everything will become into the final image. That make the message very big, and they will create a lot of other challenges. And they also make container big in size, container take more time to launch, container take more memory from the RAM. But whatever there in the image will come in the container running in the RAM. So here we need more memory also. So you will have the face of, you will also face the issue of memory, RAM. And more data than the RAM, you will need more CPU time. So extra CPU also consume. So overall performance will increase. So bigger image size is also impacting the performance of your entire system, whether Docker engine running. Okay. In some time you will see it will build and it will create a package. Okay, in the folder target with some name .jar. Okay, you will see. Okay, so what I'm doing, but I want to repeat this process one more time. So I'm going to take a push, means Control C here to stop. Okay, let me come out from this container, and I want to do everything from here only. Then after the copy, I run my run command, this Docker build command, and this build command is going to run mvn command with package keyword. So till here, till here, okay, it is creating an image where we have Java package created. But if you want to run it, then you can use entry point, right? To run this command. Run this command. This is what the code we have done till date, right? Example can be different, but this is the code we run till date. Okay. So app will be created. Custom email will be created. But understand one thing that I told you again multiple times. Okay. This is the part we need always when you run the container. This part belongs to same container image. And this image contains a lot many things my final app does not need. My final app only need this code plus Java command. They does not need actual source code. That does not Maven. It does not need any of the libraries. Any of the libraries. Okay, so let me first run this file. Even though let me take this file somewhere in my local computer. By the meantime, the building, I can explain many other things also to you. Okay, so let me build. Sorry. Again. So right now the process is going on again. So the point is now it is only one single part, or I can say there's only one single stage we're using. So till date we are using a Docker file. That's called single stage Docker file we use. Everything we put in one stage, and that means that everything will will go in one part. As this is failing, Maven package command run. Okay, for this folder. So for this, what we can do, we can use working dir, work dir. I'll make this folder as a root folder, and let me write slash here. Go into my slash location, that is my slash app, and maybe package command will run with respect to this folder. So there will be no challenge gonna come up. Work dir command you can use in this example. Okay. So maybe in package it is not complete. I think this is what I think. This is only the telling the path. path. So I have one file, guys, with me. So just to save the time, this is one file I have with me from the same guys. They have created this file. Just to quick run. So let me use this file. Okay, same file. Okay. Because this is what I explained to you. So here I'm using image. It's from Maven. Some other community has created this image. Okay, with JDK installed, and they give you Maven also pre-installed. I'm making this working directory. Okay, and I'm copying the entire source code and many other files also. So instead, we copying every individual thing, because right now in your Spring Boot folder, there's not every file we're looking for. Okay, some of the file that is important in compiling the code is mvn folder, this command, and pom file and source folder. So not everything required. So whatever we require, that's what they're copying as. So there's a hidden folder also here. Okay, so what I download from the internet, not everything required into the container. So let me copy this file here, because I'm doing with respect to this folder, Docker file. So what I'm doing, let me explain to you. I'm into this folder where code download with GitHub, and a Docker file. I'm using this image that is given you Java with Maven installed. I'm setting this working directory. Okay, and I'm copying this Maven command. This nothing is a Maven wrapper command, Maven plus pom file. I'm copying both into my app folder. Plus there's one hidden folder also, .maven. So copying. Okay, copying. And then there's a source folder where contain entire code. That's how copying. Okay, and plus this Maven also helping in resolving dependency. They download all the libraries, and instead of entry point, I'm using CMD. You know the difference. This program is saying run this code as a Spring Boot app, like a Flask app. So in the Python, if you run the Python Flask app, you can use the Python command, like Java command in the Java, or you can use Flask command also. Flask run. Here we can use Spring Boot run. So one app you can run in multiple way. So this code they are running in this way. So this is guys pure Maven command, Spring Boot command. We don't need to learn this. If we don't know, that's okay. I'm just giving multi-flavor, and let me build this code. But right now, what you see here is again single stage file. Everything, the entire code, entire Maven library, they have pre-downloaded here actually. More library they're going to download, code download, everything they put in the final image, in this final image, but we don't need. But still they put it. Okay, that makes the image big in size. Okay, because everything we are putting the one single image because single stage built. Okay, but app will run, but image size will be very big in size. But now what we can do, this code we can divide into two stages. Two stages. Okay, and what we can do here, what need a base image that contains Java and Maven. We want my working directory. I want my Maven hidden folder that contains a lot of Maven library pre-downloaded they give to us. I need Maven command, pom file that made by Maven. I want to run this command that will download many other libraries. That's what you can see here. They're downloading. That is the library that will help you in building the Maven software. Okay, so that's what I am putting here and plus my source code. So only these things I want here in my build stage. So what you can do, you can tell from here till here in build stage. And every stage we can give a name. And how we can give the name? We can give the name with the help of from keyword. From has a keyword called as. This is called alias, nickname. And here I can give the name called build. It's just a name, you can give any name. My build, base, hello. Okay. So from has sub keyword called as. As means alias. Alias means from here till here, whatever you have, I'm giving this entire part a name or nickname called alias. This called build. Build. That's what I'm doing here. And now, what is benefit of this, guys? Guys, now from here, this is my stage one, where I'm using this image. Let's say this image contain Maven in according to my example. My example. Okay. Now after this, what I can do? What I can do? I can I can for example, what I can do here, I can create one more stage. So my first stage is a lot of softwares. This is what I'm using. The entire code I'm copying and building. Okay. And in the final image, okay, I'm going to use some other image. And because you're going to use other image, you can use the keyword of from. And you can use some image, okay, some image, maybe from this guy, some other guys, that only contain, because you're going to run only Java image, right? Your Java code. So you can use some image, there's very basic image, or maybe distro less image that is only Java runtime. Java runtime. Okay. And what this image contain? It's contain very minimum thing of Linux with only Java command. Okay, only Java command. Okay. But only Java command is not required. I say we need a package also. So this run command getting the package. Okay. Or maybe you can use because this is not complete actually. After we copy this, we have to run one more command. Okay, and this command is called mvn only mvn command or mvnw command package. Okay, this is what I show you in this page also. Okay, and then build process. Okay, and then after this, then they will create software somewhere here. Somewhere here. So what I can do, I can tell my CMD that I want to run this command. Let me put this command here. Okay, but for this command, I need base wares that contain Java. They will give me. I'm just giving some random name here. Okay, and to and to get the package, this is the main part, right? From where you get the package? You get the package from this part, and this part block we are given name called build. So here, what we can do, till date, you know the copy command, guys. Copy command will take the software from base system. So it'll go to base system and they copy something. But in the copy command, there's one more option we have. It's called from. You can get some software from other stages. There's a stage called build stage. That's what the name we are given. So here you can say, I have a build stage. So I'm referring to this part. And this guy into their workspace, into their workspace, it is in the target folder, because moving guys behind the scene create target folder automatically. They create an app .jar file, some name .jar file. Okay. And they have into this folder. I want to copy into my current my current uh, image into one folder. Let's say Linux world.jar. I want to copy it. It will be my personal image or my final image. And this image also you can give a name if you want. There's a final image, just a name. I have my personal image into this folder. So here I can run. Wherever I copy, I can run. Okay. So what you have noticed, this is what exactly I explained to you. I explained to you. Okay. So this part, what you see in the left side, this part we are doing from here. And now guys, this first time you've seen from keyword 2 times, right? That means I'm using 2 base images. This form base image I'm using for the for build purpose. So this is stage name is called build stage name, where they contain Maven, Maven command, so that I can create a package. Plus they contain source code also. So this from keyword will create one image. This is called built image, and this image they will run in the container. They help me to create a package, and that's all. That is in this image. What they create in between when you run this entire file is also an intermediate image they create. But this I'm doing only for the build purpose, the way I explained to you. After package created, okay, into their folder, in target folder. Why target? Because Maven is the one who always creates target folder with this name. I'll copy this file not from a base system. I'm copying from the build stage. But if you don't write this, if you don't write this, then they feel I'm copying from base system of my Docker engine. But no, I'm copying from build stage. Okay, to their area and this file into my area, my final stage to this location. And because my base image, what I'm using in my final is one, it could be distroless image or it could be other image also. Only thing what we need here is Java command. I don't need Maven command. I don't need any software of my app. I need only Java. So technically, this is the final image you're going to create, and this image that I'm going to run as my app. This image I'm going to run as a container. This image I'm going to use a CMD entry point or run my app. Or this image I'm going to share to my other team. Okay. So in one single file of Docker, if you are creating multiple stages, and every stage they have a specified thing to do, that's called multi-stage build. And it's not like that only 2. You can create multiple also. You can install multiple also. You can do what you can do. Okay, you can use this guy as a base image, just a name. Okay, base. Okay, this part, what this stage is doing is just a name of the stage base. What this guy is doing, they're only copying the code, copying some POM file, and solving some dependency of Maven. Then we can use one more from. And in this from keyword, you don't need to tell the image name. You can also use the intermediate image. So this is the intermediate image name also. So a name you give to this a block, This is called alias name, but this is also the name of the intermediate image what they create. So again, say whatever the image they create, what content they contain source code, maybe in software, maybe in command, maybe in some other library dependency resolve, whatever they're doing. So they will create one intermediate image called base, and this image I want to use, and in this image I want to do Maven package command, my build command. So this stage also I can give the name, do build. Okay, and this is the one who actually building the package. Now here, my final stage, I'm taking what a build stage is created. Okay, I want to take the code from there and copy into my final stage. So there's a multiple multiple um, uh, stages you can create. One stage doing something for you, like it is setting the base for the main part. Then second stage, it is only building part, compiling part, creating package part of Maven. And whatever they create, then I use a final stage, or you can give a name production stage, whatever name you want to give it, your choice, nickname. They're helping me to run it. But whatever you create, put in the last, that would be the final image. And that is image you are going to use in your production environment or running the app. And that is the only one who contains CMD keyword or the entry point keyword. Otherwise, other guys will use copy command or run command because they are the one who only run the build time. But CMD's entry point is the one who run the container runtime. So only final line or final stage will contain CMD keyword or the entry point keyword. Okay, that's how it works. So in the last code, what I write is one single stage file. Yeah, the command may be different, but this is the file we created. And if you see images, it has been created. So still I didn't use the package command. It will make more big in size if I get the package command that mostly we use. Okay, the size is more big in size. And because this image is created, I can use docker run idit. Okay, and that's all. Let me give the name os1 new content launch from this image. From this image, and if you try to curl, I think IP maybe this one, port number 8080 or whatever the port number would be of this guy, but it's it will work. Just go and check the port number, I think also. Or maybe I can use the docker logs command to see what is happening inside this OS. You can see this OS is running, showing you some output. Something is going on. Okay, so when your OS running in the background without going inside this OS, you want to see what is the output coming on the cell console log. You can use log command. You can see what is happening inside this container. You can see this. So this is what they're doing something. Maybe they're downloading some other things also. Or mostly guys, when you run the Spring Boot app, it takes some time to load. So I think Spring Boot app is still yet to start. But when they start, then only the port number 80 will start. Then only you can able to connect. It takes some time to connect. Okay, you can check this. But whatever the way example you say, it is a single stitch. Okay, the size of the file image is very big. Still, I didn't use the package. But if I run this code, then you can see the file image is very, very small in size. So for this, what I'm doing, guys, the same Spring Boot guys has given us this file, this multi-stage file. The main portion of this file I explained to you. Okay, so I'm using some base image. This blog stage name is called base. You can give any name. This blog is only copying the code, installing Maven, and downloading some libraries. Okay, then from this base intermediate image, I'm creating one more intermediate image called development, or development is also the stage name. Okay, what they're doing, they are running the Spring Boot app. Okay, and they are doing something that's not important right now. So this part is not important. I can skip this part. Maybe they are doing some development test, something like this. I don't require. Okay, so this part I remove. Then from the base image, I'm creating one more intermediate image called build, or I can say this is a build stage. I'm creating the package. And the third, let me remove this line. So third stage is the production or final. Okay, I'm taking whatever we create here in the target, I want to copy to my system and then run Java jar command. And what you find here is not related to Docker, it's a Docker Java commands. So we doesn't need to know much about this right now. So this is a good example of multi-stage. Okay, so let me remove the previous file, create a new file. Okay, and let me remove this part. That's okay, I believe. Okay, and now what I'm going to do, I'm going to create a new image or build a new image. Okay, let's say Linux World Spring V1, and what you will see now, they are running one file, and here what you see, right now they're done run the build stage. Okay, and technical build stage is this one. This one. This part they're not doing because this part I already did in my last code. So they have my local repository created. So they're done very quickly. So they move to this stage very quickly here. So right now what you see here, my build stage is running. This is the one who running this command. This command. Okay. But before this, what you see above is come from cache. Why? Because in my last example, I have run this part from some other file. Whatever file I use does not matter. They have my local base intermediate base pre-created in the cache, so they run this time very, very quickly. This code. But technically, when you run first time, they will run first stage, this one called base stage. You can see here. The second stage, what you run is called build stage. You can see right now. Now Maven is building the package. And I told you already that while building, they download libraries. And whatever need for building Maven and the code, they have everything. They have everything over here. Okay, why they have here? Because this build stage is taking the entire thing from the base image or base stage. So they have everything, right? So again, I'm going to repeat the stage name what you give is equals to image name. It is equals to intermediate image name because they are the intermediate. We're using this one, then this one, and this will be final image. That is what we use finally. Okay. And after this stage run, then we run this stage called production stage. Okay. And they are the one we are using CMD or the enter point. And this is the final image we are going to use. Okay. So I think this topic makes sense, guys. Okay. So again, very quickly, if I revise, do we need to use multi-stage build in every app? No. Okay. But if you think, maybe let's say Python, if we talk about, if you think some portion as a preparation stage you want to do, Okay, just rolling Python, just on library, and give this stage a base, you can give. Then this base stage where you prepare everything, then you can use the production where you run the Python Flask app. Okay, or maybe Python app might need some database information connectivity. Then this could be, for example, the one they are trying to do here. Maybe you can do here. So here I can give some information, maybe as an environmental variable to talk about Flask. You need databases information. I'm giving you as an environmental variable. For example, in my last example, I was using WordPress. So here I can prepare everything about WordPress. And then I use one more image and say, now you need some extra information up to know the database information. So I'm giving some environmental variable about the databases. And then one more image from this guy, we can prepare as a final image where I'm running entry point CMD WordPress app. Okay. So that could be done. Okay. Just to have intermediate stages that equals to intermediate images. Okay. So, but it does not shrink the image in this case because we are finally putting everything in the WordPress image. But in the example of Java, okay, in the final image, if you see this final image, I'm not taking from build or base. I'm taking some other image that is a distroless image maybe that only need Java command come from this distroless image and my app that come from this part, only the image, the package. So in this example, okay, the multi-stage build can help you in shrinking the image size. Okay, but other example, multi-stage, you won't see any shrink. Okay, but if you create multiple stages, then sometime it is useful. I want to launch a container from this image. I want to launch a container from this image. So because you have multiple images with you, so you can take any images, and from there you can launch the container from this image. This means if I launch the container from this image, then I can only get this. Maybe I want to do for some testing purpose. I don't want to launch my container finally with the app. Okay, particular layer is like a layers actually, kind of layers. You can receive, you can get to launch your container. So you can own that container. You will, if you launch the container from this image or internet stage, I will get only this part plus this part. Then on the top of this, whatever you want to do, you can do. But till this part, we don't have a Java command running. So my app will won't run or won't run. That I don't want because I want to test something else from my side. Okay. So in that context, your other app like Python, where does not need build like Maven. So there you can use multiple stages. Okay. So guys, fantastic. This is working with some warning for XYZ reason. That's not important right now. But if you see your production stage also work. Okay, and finally they are the one who add okay this layer. Okay, that's what they created, and right now I created a image with called LW Spring 1. So if I run the Docker images images, here you can see LW Spring V1 gonna come up, and if you see the history of this image, then you can see there's a lot of what exactly I want to show you. But here you can see in the history, this image only contain what you have in the final stage. This image does not contain anything about base image or the build stage. Because normally history, you see what we have done, right? We see here, we have Java command, expose command, Java command, expose command we have. And what you see extra is come from this image actually, whoever created this image. So this information come from the remaining image, but you does not have anything about prestige. You don't have anything about uh, any other intermediate images. That means that means if you see the images in this image is very neat, okay, you can see this image is very small, very small. Okay, comparatively, if you remove these lines, then if you run it, then I believe this image may be more than 800 to 1 GB in size. Okay, just try this. Even though without Maven also, last time when I show you, okay, that was this image was was some 500 and so on, right? Still there, I did not run the Maven package command. Without this, there was 578. If I had Maven package, will be 400, 500 MB data more gonna come up. Is would be 1 GB in size when we go for single stage. Okay, but when I divide into multiple intermediate stages, the final image that contain what we're looking for, Java command in the package, is only 354 MB. But if you want to make it more smaller, then don't use this image. With this image, I take the example from this guy. Okay, I think they are not using distroless. They might have many more things extra available. But if you try to find a Java GRE distroless image and use here that only contains Java command, not extra distro thing, then the size may be some few MBs. That much difference you'll see. Okay, so that is the one point. But final image created. Now in this image, I launch a container. Maybe I use a padding here on port number. Let me have OS 2. My container launch is a Spring Boot. And because I've done the patting, so I can use curl command, I can use my local host IP address, my own IP address, port number 8080. Okay, and it will connect. It will take some time because Spring Boot app guys load will take some time. But I can see the logs very quickly. Docker logs. So they are doing, maybe they might fail. Okay, because the example what I am using right now, this pet example, they need some database connectivity. Okay, so maybe, but you can see Spring Boot app is started. They are just a kind of warning. So I'm seeing the log of my OS. This pet clinic app has been started. Okay, but if I try to connect with app, if they really need a database, then your connection might not be. Yeah, it's working out. It takes some time to start. It started right. It started right. So let me show you from my Linux system. Okay, I think this IP is 1.9. So what I can do, I'll use my Windows because I've done the petting there. This is the IP of my Linux and port number 8080. Fantastic, right? So it is working fantastic fine, and maybe some part you will say error because there might be some databases. Okay. So you can see information, whatever they have hard coded, gonna come up here. Okay. So app is not important right now. It's important right now. It's been done by some developer. The important part for you and me to understand is multi-stage build. Okay. Right now, what you app you're seeing If you go for single stage, also same app gonna come up. There will no difference gonna come up. Only difference that you will see is the size of the image. Right now is almost 350 MB, but the size may be around 900 to 1 GB, 9 MB to 1 GB. Okay, and if the image size is big, then it will cause many challenges. And what challenge they cause? If you want to share with the other team, it takes some time to upload, download. If it's as big, it will some time to form launching the container takes extra time. Then container take more memory and CPU while running because of extra data and extra things to be performed. A bigger surface area that will lead lot many security, CVs, vulnerability issues. So it's not only the size, it's about many factors. So that is we are very much concerned about image size. Okay, and plus here planning also we have done very properly. Okay, so we different stages. Every stage we are planning according to what stage is doing. So anyone who know CI/CD pipeline, it is kind of CI/CD pipeline. Okay, this is more like a SCM. We are managing source code management. This is the build stage, and this is the deployment stage. So kind of whatever you done normally with Jenkins. Jenkins is a big tool, obviously. I can't compare, but it is kind of CI/CD pipeline where we are building. Even though we can write one more stage here for testing, we can run maybe test command. Okay, so that also we can do. So it is more like a complete CI/CD pipeline kind of concept we have created here. That's called multi-stages with the Docker. Okay, so I think guys, a lot of things we have discussed today. I'll share those two links to you. This is one of the link as a single stage file. You can take. I'm sharing here, and this is the app code in GitHub. Okay, and this is a multi-stage code. Okay, so that's it, guys, from my side. Hope you enjoyed this topic, and I suggest now onward, whenever you create Docker file, try to create multi-stages whenever it look like relevant in terms of management, in terms of image size is small, in the terms of if you think something you have to do once, and remaining thing you do again and again. That is ideal to think. So what I want to think is once put in some intermediate image stage, and what I want to do again and again, take as an intermediate stage, launch a new image, and run in the CMD or entry point. So this is a very quick way to think of how to create multiple idea or plan behind to create multiple stages. Okay, that's it, guys, from my side. And any queries, if you have, you guys can ask me. So I believe no. That's all, guys. See you in the next class with some more beautiful, beautiful concepts of Docker. Bye. See you. Take care.